Hi, Math 157ers. This is Professor D, and I'm going to take you through a couple questions 7 and 12 on homework 4.3 to kind of show you how to use StatCruch to help you through this chapter. So question 7, the accompanying data table contains 2 body measurements in centimeters for college women. Hand width is the width of the hand and the finger with the finger spread wide. An arm span is the span of the arm with the arm spread wide. So we're going to see if hand width is a predictor of arm span. So the first thing they want you to do is make a scatter plot of the data. And if you look, hand width is the predictor variable or the x variable. Arm span is the response or the y. So we're going to click here, and hand width, arm span, and just right next to the arm span, there's a little box that says click the copy table. And if I click it, and I click open in StatCruch, I can open it in StatCruch. So what I want to see is a scatter plot. So I'm going to hit graph, scatter plot. X is hand width, Y is arm span, and that's all I need to come up with a scatter plot. So this scatter plot looks sort of all over the place. Hand width, arm span, so it kind of looks like there's no real correlation, but let's see which chart looks most closely like this. Interesting, because when I look here, this doesn't really look like anything on here. So if you have to look here because they said this was between 140 and 180 and 10 and 26. So I'm wondering if we go back into edit, group by, line size, default, horizontal, use same X, line size. So here's one of the problems with StatCruch and some of these in here. So it does not look like we can change our doesn't look like we can change it, so we're going to have to try to make a guess. Well, it sort of follows sort of point process, right? We've got 15 and it looks like 15 and a little bit higher than 160. And it kind of, overall, it seems to go in and then back out. So let's see what we can get rid of. Pretty certain that we can right away get rid of this because it doesn't point in this direction. And we can probably get rid of this because it looks like it's sort of a dip curve, and this one is kind of an up curve. So the only one that it could follow, I think, is A. So let's go with A, and we were right. So just be careful if you're comparing your scatter plot to the one inside the software. Look at the axis. See, this one started at 15, went to 20, and this one goes from 10 to 26, and 140, which we had here, to 180. So it's just a little bit off. So you get the same idea for the shape, but it's going to be a little bit different. So continue. All right, why isn't linear regression not appropriate? Well, it doesn't follow a line. So let's see, why is it not appropriate? Well, let's look. Linear regression is probably not appropriate for these variables because hand width should have no effect on arm span. We don't know, because if you look at in this graph, it looks like it has some sort of relationship, maybe, but it's not linear. And so really what you're looking for is why is linear not appropriate? Because the trend is not linear. We're going to go with C. There you go. All right, so now let's go look at number 12. And I worked through these before I did this, so I'm going to click here. And it says, the company table shows the population in hundreds of thousands and the number of motor vehicle fatalities in 10 states. Complete parts A through E. All right, so first of all, if I just had to guess, the population and the number of motor vehicle fatalities. So my guess would be states with higher populations are going to have higher motor vehicle fatalities because you just have more people living in them. So the correlation and slope will be positive or negative because states with a larger population will most likely have more motor vehicles. So let's go with positive. And so if you're a bigger state, you're going to have more motor vehicle accidents. That's true. All right. So we got to come up with a scatter plot. So let's look at the data. And if we see here, population is our independent variable, motor vehicle fatalities are dependent variable. So our X is population, our motor vehicles is our Y. And what I found interesting here is they actually list them in reverse order. So oftentimes I always think there should be an X here and a Y here. So just be careful when you're working in these. So I'm going to click open in StatCruch. And then we're going to go to the graph again, scatter plot. Remember, population is my X, motor vehicles are my Y, compute, and let's be real careful here. Our population starts at 0, as does our fatalities, and definitely has an upward sloping trend. Okay, so let's see which one would follow that, or which ones we could actually get rid of. Well, right now, Table A says has a downward sloping trend, and so does Table C. Okay, so we can eliminate those right away. Now the question is it going to be B or D? Let's go back and take a look here. And what's interesting is our scatter plot has a lot at the beginning and kind of less at the end. Well, this one has less at the end, less at the beginning and more at the end. So I'm going to think this one has more at the beginning, less at the end. I'm going with D. Okay, so what's the correlation? So I need to find the correlation coefficient. So we come back here, we go stat, regression, simple linear. Our X variable is population, our Y variable is motor vehicle fatalities. I hit compute, and the correlation coefficient R is 0.9519, so I'm going to go with 0.952. So, predicted motor vehicle fatalities. Let's look here. Is equal to some number plus some number times population. What StatCruch does for you. So here's our regression line. So our intercept is 26.04, and it looks like our slope is 9.00. We'll have to go with 5 times the population. I think that was right, 0.040. And we're going to go with 9.005 here, 3 decimal places. Yep, we're good. So what does the regression line look like? Well, again, it's upward trending. So it's not going to be B. It's not going to be D. And if we think back to our scatter plot, we had kind of these 2 points at the end. So it's probably C. But let's take a look here. What's really kind of cool about StatCruch is it does that regression line for you. So clustered points here, 2 sort of outside points here. I'm going to go with C. All right, so what is the slope? Come back up here. The slope is what is being multiplied by the population. So our slope is 9.005. And remember, our population is in hundreds of thousands, okay? So the slope is 9.005. And that indicates that for when we increase the population by 100,000, okay, because the population, the X variable is in hundreds of thousands. When we increase the population by 1 in terms of our regression line, which is really 100,000, we'll increase our motor vehicle fatalities by the slope, which is 9.005. So you have to pay attention here to the units that they're using. So when they talk about an increase of 100,000, you think, oh, that should be 100, comma 000. But if you look back in here, the population is already given in hundreds of thousands. So if I could find, I've got a lot of windows open here. I don't need this window open anymore. We don't need that one. If we could, here, let's look at our raw data. The population, it's not 34, it's actually 34 times 100,000. So what they're talking about here, a 100,000 increase in population on our regression line is really just 1. And there you go. And that's all I wanted to show you from 4.3, but hopefully that'll give you enough to be really dangerous in 4.3. Okay, I will talk to you guys soon. Take care.